I have a dirty, dirty secret about the implementation details of my indie game. I hope you won't judge me too harshly. Yo, so for context, I'm Kenneth. I'm working on a 2D pixel art action platformer game called Isadora's Edge. Very Hollow Knight, Mega Man X. I'm sure you're looking at some sick B-roll of some gameplay right now. I'll just get right into it. I implemented every single projectile in my game completely uniquely. They're all completely independent. All the physics, all of the animation handling, spawning, even like object pulling, all of that is completely unique for every single projectile. And I didn't even use Godot's like built-in physics for anything. Now I know some of you watching heard that and like just cringed so hard that like, like your kidneys exploded, which by the way, I am not medically liable for. Some of you watching might not really know why that's a big deal. Like, yeah, I mean, you implemented every projectile, that maybe it's like a bit harder, but like, what's the big deal? And I will get into why that's a big deal. I'll explain it quite thoroughly. But before I do that, I need to introduce to you a new enemy in the game. Check it out. This is Bonnie. She's one of the mushroom people that live in the corrupted forest. I designed this whole society of mushroom people in the forest, and so I have the Ushroot and then the corrupted Ushroot, but I felt like just having one type of mushroom person felt a little bit like, is it really a mushroom society? So I also added Bonnie, and she's based on this plant called the bleeding bonnet, which is a mushroom that it looks like it's like this pretty white, like pale, like it's just a pretty little mushroom, and it releases this sap. Looks kind of like the mushroom is bleeding. And so the inspiration for her is that before the corruption happened in the forest and the mushroom society was like destroyed by the corruption, and she was like the pretty princess type, right? She was like very beautiful, and they would put like fancy like mushroom fashions and stuff like on her. And the whole theme of the forest is like a perversion of love, right? It's like everything in the forest is themed on disgust. And so she represents like the disgust in terms of like visual, people being disgusted with themselves instead of like an outward disgust. It's very like Left 4 Dead coded, like, you know, the witch, how she just sits there crying. That was definitely one of the inspirations for this, where she's kind of like, you know, pulling on her mushroom cap and like almost self-soothing because she doesn't want anyone to see her anymore. And then if you get really close, she'll like lean down and launch these orbs in the air, her like pustules that she's growing. Is pustules the right word? What does that mean? I'm gonna Google pustules. Gross. And the reason I have to introduce you to Bonnie is because I tested a lot of my projectile stuff using her. So there's going to be a lot of footage of her like throwing her projectile. So I figured it was important for you to meet the character before she just starts showing up and stuff. So anyway, back to the main issue on this video is, why is my projectile system so bad? Why is implementing everything by itself like an issue? And there are three main things. First is the time commitment. Implementing every single projectile by hand with every feature of every projectile by hand takes a long time. It's just a lot, like it's a lot of projectiles. It's like, I think so far over the 2 years I've been working on this game, I've probably spent, I don't know, 50, 60, maybe 100, I don't know, a lot of hours just hand coding all the behavior of these projectiles. If I kept doing that for every projectile I want in the game, dude, this is not gonna release till like 2047. I have no idea. Clearly it takes up way too much time to do it like this. It adds up when you're doing everyone completely independently. So it takes a long time to add new projectiles. The second and more important issue is that it makes the game like completely unmaintainable. And I have a concrete example I can give you of exactly what I mean with this like unmaintainability. So I was working on the level design for the corrupted forest, which is something I think I've said a lot recently, but getting it really good takes a lot of time, and I want to put that extra little bit of that little loving, caring, whatever. I want it to be good. I've been spending a lot of time on the level design, and I implemented this new mechanic that I was trying, which I've been calling lifters, where there are these little platforms that after a set amount of time, they like launch into the air and then slowly come back down. And they have a sort of like momentum building thing, like how Celeste does, where if you use one of those auto moving platforms, you can get some extra distance. Plus they can create like temporary platforms as they fall. It's like, they've just been a lot of fun to platform around on. And as I've been using them, testing gameplay with them, they feel really good. So I've been pretty happy with the lifters, and I wanted to test out some combat. And so I threw in a bottle sprite just to see what it would be like. I was like, oh, she can cycle through her projectiles. I can see, you know, which one feels the best. I was thinking maybe her fireball potion would feel the best on the lifters, and, you know, just play around with it, see how it feels. And you can see the issue that happens when her potion hits the lifter, it doesn't react appropriately. Honestly, it just like slipped my mind when I was implementing her potion. It's just something that I never even thought about doing, right? I never even considered, let's make these potions interact appropriately with a moving platform. Now, that's okay. Making them work here is not particularly difficult. I could go in and add that moving platform support to the potions, but then what about Nuvdu's egg? That will also not work on these lifters. And what about Ushroot's little like spore thing? That will also not work on these. I would have to go through every projectile and make sure that it behaves appropriately on these moving platforms. And because they're all completely independent, they don't share any functionality, I will have to go through every single one and make sure that it happens. And if I miss anything, that one projectile will be like extremely bugged. And that transitions nicely into the third main issue, which is the fact that I can't add projectile-based features very easily, if at all. It would take forever to add any kind of projectile-based feature. And the most obvious example is, what if I wanted to give Isadora the ability to reflect projectiles? Like once she gets a certain badge or once she beats a certain boss, she can swing her sword, and if it hits a projectile, it will like launch it back the other way. Or like she gets like a special shield or something like that can reflect a projectile. And when it reflects it, it could even like flip the hitbox so that it hurts the enemies instead of hurting Isadora. Like something like that could be really cool. It'd be fun to be able to like prototype it, play with it, and see if it works. But the issue is, if I wanted to do that, I would have to go through every projectile I've ever added to the game and implement like this reflectability concept into it. Otherwise, that projectile won't be able to reflect. It would require me to go through every single one and hand code that reflection piece for all of them. Now, I could make like a node that's like a reflector node and add that to every projectile, but the physics is hand implemented and doesn't even use Godot's physics system. There's no guarantee that this generic reflector I built will work well with any projectile, and then I have to figure out how to integrate that into every unique projectile. It's just a ton of work. It's so much work to get that working on every projectile because there's nothing shared. So having laid all that out, I think it's fairly obvious why the current method of doing it is like not sustainable. I need to stop hand implementing projectiles and do something better. You might be wondering to yourself, why did you even do the projectiles like that in the first place? Like what is the point? And honestly, it was mostly just a time thing, where spending 30 minutes like quickly hacking up a projectile just so I can test it and prototype it it's a very seductive compared to the amount of work it would take. Like, you know, if I don't want to spend like 10 or 15 hours slowing myself down and going and implementing like a generic projectile system that I can use for everything, when I really just want to like test out a thing for this one enemy. I always in the back of my mind was like, eventually I'm going to need a generic system, but you know, I'll do that in the future. I don't need to worry about it right now. This is all prototyping. I just want to be fast and lean. I don't want to get stuck in systems hell. You know, eventually I will make a system for this. It will be awesome, but don't worry about it right now. The future is now, old man. The old man version of myself. The old man version of myself that went back in time to implement these projectiles. I've lost track of this metaphor. So now that we've defined the shit out of this problem, what are we going to actually do to fix it? Like, how are we going to fix this? What we want to do is create what I'm calling the generic projectile physics controller. It's a node that handles every single aspect of moving a projectile. If you want it to shoot that way, you need we have this node here, the projectile physics controller. If a projectile wants to shoot that way, it tells this node shoot that way, and it does it. If it wants to do a loop through the air, it tells this node loop through the air, and it does it, right? This one node controls every aspect of movement for every projectile. Obviously, every projectile will have its own copy of this node that does it, but this one node exists inside of every projectile and handles all movement. That means, for example, if we want to support moving platforms, we just make it so that this node understands what happens with moving platforms, and then boom, every projectile understands what to do with moving platforms. If we want to make Isadora able to reflect nodes, we just build that reflection capability into this, where it's like the thing that moves projectiles understands how to reflect itself. Now, every single projectile in the game understands how to be reflected. We don't have to necessarily turn on the reflection for every single node, or every single projectile understands how to do it. And spoiler alert, I already did it. I made the generic projectile physics controller. I went through and defined everything I thought I would need. Like, here's what I would need to be able to use this for every projectile that currently exists in the game. And then I want to get that working, get that done. And then I can convert all the projectiles to using it, like all my 2 years worth of projectiles. I can convert them all to using my projectile controller. And then if I need other features in the future, that's a fun sentence, I can just add them to that node and we're all good. But I was going to go through and list all the things I came up with that I needed. But a lot of people have been asking to see more editor footage. They want to get a more practical behind the scenes idea of how I actually do the development. They want to see like what it's like working on the game from a more like direct viewpoint instead of me just like talking about it to the camera. So I figured I can show you in editor exactly what my projectile controller does and what all the features it has, what it's capable of, everything that this projectile can do, and explain to you how it works. And so boom, here it is. You can see there's like a bunch of settings, a bunch of features that you can tweak, and all kinds of numbers you can edit. And I'm going to go through all of them and explain them. Some of them are really easy, really fast and simple to understand. Some of them are going to require a little bit more of an explanation. But so the very first thing you can see is run on spawn. Run on spawn, if true, the projectile will immediately start moving as soon as it enters the scene. If it's false, whatever does the projectile handling, whatever projectile handling script will need to start the node by like calling enable on it. And Bonnie is a great example of this feature. When she spawns her projectiles, she doesn't want them to immediately fire. She like pulls her cap down. She wants them to launch when she does her animation. So we turn off run on spawn, and then when she does her animation and launches them, that's when they get enabled and move. So that way we can handle the spawning and enabling of the projectile separately if we need to. But if we're just like shooting something and we just want it to go as soon as it's there, then we just turn it on and it's all good. Gravity enabled is very straightforward. If it's enabled, then gravity will slowly pull the projectile down over time. And if it's not on, then it won't do that. So for like a video game, you just move in a horizontal line. We don't want any gravity pulling it down. You just turn it off and it can just go in that straight line. For a more physical object that we want to like more mimic real life and we want it to actually come down with gravity every frame, then you just turn gravity on, which leads you into the gravity value, which just determines how much gravity to apply every frame. Basically, we can use that to determine how quickly it's going to fall down, right? That's how gravity works. Gravity is pretty straightforward. We can customize the gravity for different projectiles. If we want something to feel light and floaty versus like really heavy, we just change the gravity so it falls at different speeds. And then that leads us into horizontal move speed and acceleration, and then vertical move speed and acceleration, which do exactly what they sound like they do. They control how fast it moves in the vertical and that's not vertical, that's horizontal. It controls how fast they move in the horizontal axis and in the vertical axis. That's what does the actual movement of the object. It moves based on these values here. But that takes us into the use ballistics flag. And this is a lot more complicated. So I set up a ballistics trajectory calculation where we can supply the projectile with the target we want it to hit, how long we want it to take to get there, and how high we want the arc to go. And then it will take all of these values in and calculate the like move speed, the acceleration, and the gravity necessary to produce that arc. So I can even probably flash up the math on screen. It's not a very complicated equation. Like the math for it's actually very like small and compact, but this mathematical function produces the values we need to simulate this arc. And so if we turn on the use ballistics flag, instead of using whatever values we set up there, it will use this arc height target and this arc duration to calculate the arc we want it to take. Primarily, we want to target the player with this, where it's like, shoot this in an arc at the player, take 1 second to get there and go this high in the air. But we could actually target anything. We could set up a bunch of ballistic targets along the ground so it just like comes out in a fan. And actually, I don't know if that explanation was super clear. So let me show you some examples in the game using the bottle sprite, throwing her bottle at the player. If the arc target is high and the duration is low, like it's a quick one, then it will very quickly go high in the air and then down at the player. It makes it feel very heavy, and it makes it feel like the bottle sprite gave it like a big launch. If we keep the height really high, but then increase the duration so it takes a lot longer to get there, you can watch as the bottle like feels a lot floatier, it feels a lot lighter, and it still feels like she gave it like a good chuck, but it takes a lot longer to get there because the duration's higher. Similarly, for completeness' sake, we can turn down the arc height so that she's not throwing it nearly as high, and then also lower the duration. So it's a really fast and really low arc, and suddenly it feels really heavy, and like she like gave it like a little bit of a toss just to kick it out, but then it goes directly at the player from there. And then we can do the same thing with a low arc target as well as a long duration. So she very slowly throws it, but she doesn't throw very high. This makes her look like kind of weak. You know, each of these settings produces a different feel to the ballistic arc, and they're like, you know, in theory, infinitely customizable because you can make the height as high as you want, make it go as fast or as slow as you want. And this lets us customize the arc that the projectile takes based on how we want the actual arc itself to feel, rather than like fiddling with numbers. Like, what if I turn the vertical move speed up by 12? How will that feel? You know, what if I increase the gravity? I don't have to like fiddle with it. I can be like, yo, I want this arc to arc a little faster, and then it'll just handle calculating the different speed and acceleration and stuff for me. That makes it way easier. It's so much easier to come up with these projectile arcs using these values and then converting it using the like ballistics math. So much easier than doing it by hand. Like, it's orders of magnitude faster. Yeah, it's like orders of magnitude faster. It works really, really well. I'm really happy with like the ballistic simulation stuff. Then after the ballistic stuff, we have pass-through environment. If this is turned on, then the projectile won't like, you know, it'll just go right through floors. It won't even register them. It basically turns off the collision for the projectile. It's very straightforward. And then after pass-through environment, we have stop on floor. If this is enabled, the projectile will stop moving when it touches the floor. This is really convenient for playing like burst impact VFX, because otherwise it would keep moving while the burst plays, and that looks really weird. In fact, let me show you. Here's what the projectile looks like when it continues moving while it's playing the burst impact. You can just tell it just feels wrong. But if we instead stop when we hit, we can watch that now, and boom, suddenly instead of moving along the floor while it bursts, which is weird, it just pops in the spot. So stop on floor is very convenient for getting that projectile that just like shoots out and then explodes when it touches something. A little bit further down, we have stop on wall and stop on ceiling. Those do the same thing, where if it touches the wall, it stops, and if it touches the ceiling, it stops. It's exactly what you think it does. Then underneath the stop on floor, we have bounce off floor. If this is enabled, then when the projectile touches the floor, it'll flip the vertical movement and go the other way. So, you know, if it's moving down at 100 units and hits the floor, it'll bounce back up at 100 units. So we can watch, boom, we got bouncing turned on. You can see this projectile bouncing along the floor. This leads us into the floor. This leads us into the floor bounce force. And this is a ratio of how much of the speed the object should keep when it bounces. A little bit confusing, but essentially we multiply the speed by this number before we do the bounce. At 100%, at a value of 1, we keep every bit of speed. It bounces off perfectly elastically. It keeps everything. And you can watch an example of that right now where it's like bouncing perfectly elastically and just keeps going. If we were to set it to like 50%, then it only keeps 50% of the speed when it bounces, and you can see it like slowly trails off because it's losing speed every bounce. I mean, in theory, if we wanted to, we could set it to like 1.5, like 150%, and gain height every time we bounce, which I can't think of a use case for in this moment, but we can watch it happen. My system supports it. This is such a funny feature that I added where there's one projectile in the game, the lightning that shoots out from the bottle sprite. I wanted it to bounce off of the walls, and I have spent so many hours on that stupid lightning projectile that I wanted to bounce off of stuff because I wasn't using Godot's built-in physics, which makes bouncing off of stuff much harder. I tried raycasting at one point, I tried bounding volumes, I did so much stuff to try to get this bouncing working, and every time I thought it worked, I would put the bottle sprite somewhere and the bouncing wouldn't work. I've been trying to get bouncing to work forever, but then I just added it to this generic projectile controller using the built-in Godot physics, and it works wonderfully. It's crazy. It's like really nice and also really annoying. I don't know what I was doing. And then we have the bounce off a wall and the wall bounce force, and then the bounce off of ceiling and the ceiling bounce force. Those work exactly the same as the bouncing off of the floor. We can see some examples of bouncing off the wall and bouncing off the ceiling. Boom, ooh, look at this in-game footage. Boom, 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 boom. You know, it does what you expect. Except for, I guess, when you bounce off of the wall, it flips the horizontal speed instead of the vertical speed. But I'm sure you assumed that based on everything I've said so far. Then there's one more field that I sort of skipped over because, you know, all the bouncing stuff is sort of interspersed there, which is the max bounces off a floor. Whatever you set this to is how many bounces it can have. So if it's set to 3, the 4th time it touches the floor, instead of bouncing, it will just stop moving, right? It doesn't stop on floor until it hits that final bounce. And if this value is set to -1, it just like ignores the field. It's the same as like turning it off, basically. If I were working on this in a professional setting, like if this was Halo Infinite, I would have made these fields like expand and collapse based on what's selected. You know, the ballistic settings only appear if you click use ballistics, that sort of stuff. But I'm the one working on it, so I don't got to put in that extra effort, baby. Woohoo! It's lazy time. But so those are all the customizable fields of the projectile controller, which is almost everything. All that's left is the signals, and these are really straightforward. We have hit wall, hit ceiling, and hit floor, which are signals that get emitted by the node when it hits the wall, the ceiling, or the floor. It's very straightforward. It does what you would expect it to do, and it's useful to let the projectile handler script play the like burst impact VFX at the right time, or to handle movement, like turn off the hitboxes and stuff. It's very convenient for handling all the stuff that needs to happen when the projectile hits something, right? And then we have movement stopped, which is a signal that gets emitted when the movement of the projectile stops for any reason. If it gets like stuck in a corner, if it like rolls and it runs out of speed, or if it like finishes bouncing and stops on the floor, if stop on ceiling is turned on and it like sticks to the ceiling and stops moving, it'll emit that signal, which I don't really do anything with right now. Right now that signal doesn't do too much, but I feel like it'll eventually be useful, so I threw it in there because it wasn't hard to do. So that's the generic projectile physics controller. It'll exist in every projectile in the game and handle the movement for all of those projectiles. But one thing that did worry me a little bit is the fact that I am using Godot's built-in physics system. Previously, I was using just whatever physics I wrote, right? So I can control it very, very fine-tuned control over the physics. But with this one, letting Godot handle a lot of it made me a little bit worried. I was a little bit worried about how it would scale. If I have, 50 projectiles on screen at the same time, can the game handle that using Godot's built-in physics? I figured it probably can. Like, Godot is pretty good at that, especially for any sort of modern device. And even like, toaster PCs will probably work just fine. Probably won't play on the phone, but I don't think I'm gonna ever, release this on the phone anyway. But that's all neither here nor there because I was a little bit worried about the scalability. So I decided to test it. I've set up Bonnie to produce her projectiles, but the projectiles that I gave her are perfectly elastic. They will contribute every single bit of force to every bounce. They will bounce forever, and I don't have any maximum bounce to it. So these projectiles will just keep bouncing off of everything forever. And there is at no point where they remove themselves. They don't get destroyed. Once the projectile is created by Bonnie, it exists until the game is closed. And as you have been watching the whole time, with these projectiles being created by Bonnie and bouncing around the room, the game's still running just fine. The game has a physics tick rate of 144 ticks per second, and there's no noticeable slowdown. There are no lag spikes. It works really well up into the hundreds of projectiles. So Godot's physics system is handling this just fine. And so the fact that the chaos you're watching on screen right now with all of these projectiles bouncing around can just happen, it just works and is not an issue, makes me more than confident that this solution will work. I don't know how long the clip I have of this is, so I'm just going to keep rambling for a bit in case you need more time to watch. The fact that it can support all of this nonsense happening on the screen right now makes me more than confident using this solution moving forward. So I'm really, really happy with the generic projectile physics controller system that I've implemented. I think it works really well and was honestly not even that tough to come up with it. And I was gonna talk a little bit about the generic hitbox and generic hurtbox and the generic like object pooling stuff, all that stuff that I wrote for these projectiles, being able to use those generic components. But I already like done been yapping about projectiles for a hot minute now. And there's a heat wave right now, so I'm like melting. I need to like get out of here. I hope that the deep dive into the like editor side systems and like breaking down how the component actually works was helpful to you. I hope it gave you like some really good insight into like what it was actually like to work on these projectiles, and let me know what you thought about it. Was it really helpful and interesting to see what's going on in the editor when I'm like working on stuff, or was it dreadfully boring? With that, please like, comment, subscribe, do all that good stuff. I appreciate it. I appreciate you. You're the goated. You're goated. You know what? first off, let me genuinely say, please appreciate all the support on these videos. If you like, comment, and subscribe, that like means a lot to me, genuinely. And yeah, so genuineness aside, let's end this video with, I don't know, like a interpretive dance about projectiles. Let me do an interpretive dance. Projectile. Projectile. Ooh. See you next time, dorks.